What an awesome day, hey? It's been so many great talks that it feels kind of anticlimactic following this up with a humble JavaScript talk at the end of the day. But I'm really, really glad to be here at DevConf again, and I'm really, really glad to be closing off proceedings. So who the hell am I? Hi, I'm Mike. I think we can agree that's a reasonable facsimile of me. I work in the research and development team at a company called BBD. I do stuff. I don't think I could succinctly explain what I do on a day-to-day basis, but they still pay my salary, so I think it's all working out. I think so? Okay. I'm also a Google developer expert in web technologies. I'm also not sure how that happened or how this is my life, and I think it's primarily because of the sheer number of hours I've spent apologizing for JavaScript's weirdnesses. And this is another one of those talks. Okay. Shameless plug time. I'm a co-organizer of the Josie.js meetup group. We meet either on the third Thursday or second last Thursday of the month. Sometimes those are even the same day. And we're always looking for speakers, so you should totally come. There's lots of cool topics, and if you're interested in speaking, you should come and talk to us. So, I have a reputation at the best of times, but today I'm low on sleep, hopped up on caffeine, and prone to hyperbole. So this is your content warning. You know what you're in for. Okay. What we're here to discuss is JavaScript. In May 1995, Brendan Eich designed and wrote what would become JavaScript in 10 days. And it shows. So JavaScript's an easy language to make fun of, right? It was very confused in the early days, in the height of OO, or this newfangled thing on the block called Java. It has nothing to do with Java. So it's badly named on top of everything, and like it's got this duck typing thing and prototypal inheritance and lots of functions everywhere, and it's very easy to make fun of it, right? Everyone's like, you can add a string to a number and get weird and intangible results or things that don't make sense. But if like that's really a low shot at JavaScript, and if that's the biggest problem that you've got with writing software, then I think maybe there are bigger problems. So what I always look at is, if you look at where it came from and how we write these systems, right? We write big software systems in terms of OO design. So if we compare it to Java, Java on the left-hand side and JavaScript on the right-hand side, the Java people making fun of JavaScript would say, well, okay, well, do you have classes and abilities to create objects? And we say, yes, yes, we do. We have functions. Okay, but how would you do constructors and instance methods and like static methods? Well, we'd set functions inside the function, and then we would set functions on the function. Okay, I don't think we're making sense here. What happens, like how would you then call the inherited function so that we can get access to those base classes? And you say, okay, awesome. No, we'll do that. We just call the functions on the prototype after setting the prototype to a function or an instance of a function. And then at that point in time, they're like, okay, cool, but now how would you share this code? How would you export it? And you'll say, no, that's fine. Everything gets loaded in the global context. So to make sure that we don't get confused, we just wrap everything in a function that we immediately execute. And at that point in time, this is how people look at you. And this is how we wrote JavaScript code, right? But JavaScript isn't a static thing. It's 24 years old now. It's constantly growing and evolving and mutating. And yeah, it's got some imperfections that will always be there, and we'll explain why that is. But it's also a thing that has new modern features that we can take advantage of. So let's take a look at some of those. So we're going to start off with looking at variables and scoping. We're going to talk about arrays and looping. We're going to talk about context. We're going to talk about modules, which is really exciting. We're going to try and avoid inheritance entirely. We're going to talk about async stuff, and then we're going to talk a little bit about the role of transpilation and transpilers, right? So the plan of attack is that we're going to look at two basic rubrics. We're going to look at the 4 big browsers, so evergreen browsers that have consistent updated support, and how they support these features, and then global, which is basically everything, all tracked users on caniuse.com, and there are some browsers in there that I've never heard of. Later, when we share the slides, you can check the references yourself if you don't believe me, or if you want to understand what that means in more depth. So, going straight into it, we're going to look at variables and scoping, starting at the beginning. So var is easy, right? Variables are easy. This has been there since the beginning, and it sort of looks like it does exactly what we want it to, right? We can create new variables, and then we can log out those variables or perform reasonably complex logic on it. But as soon as we have conditional paths through our application, case in point, looking at a simple if statement, it gets weird. In this code block, you can see that we're doing two things. So firstly, we're redefining the variable, and then secondly, we've got this blurred sense of once it gets redefined, where did that variable belong in the first place? And this seems like a contrived example, but stuff like this happens all of the time. And the reason why this, or we can see another example of this happening when we start writing loops over arrays of data, or when we start writing more complicated applications and doing any kind of asynchronous work. And in this case, we're using set timeout just to represent some kind of async work that we're doing that we're going to wait on. Now, it's very easy to fall into this pattern where it gives you unexpected behavior. In this case, of every single iteration of the loop, it logs the exact same value. Now, the reason why that happens is because JavaScript has this thing called hoisting, where it will hoist variables to the topmost containing function scope. Now, there's no function here, so it hoists it to the top of whatever the script that's been declared. And then when you look at it like this, you can very clearly see that problem. Oh, obviously, the variable is sharing the same thing and being reset every single time. So by the time set timeout gets called, it's the same bit. So how do we fix this problem in old JavaScript? We wrap it in a function. So if you wrap it in a function that immediately gets called, you can see that the var doesn't get hoisted outside of that function context. But now I know what you're saying, right? So there's got to be a better way. So let's look at let, for example. So let is a different way of declaring function or declaring variable references, which works exactly like we expect. And now this may or may not come as a surprise, but then when you declare let inside a specific block scope, like a conditional block scope, it lets you redefine it, but it ties it to that block scope specifically. So we get what I would see as kind of expected behavior, right? When we then look at that for loop example, it does exactly what it is expected to do because it's tied to every single execution of the for loop, that scope. We're going to have an honorable mention for a very simple one that's also something that you can use called const. And const basically does what it says on the box and doesn't let you redefine variables, which is actually a really important thing because we shouldn't be redefining references to the same objects or resetting those references. There's weird side effects to that. We look at the browser support, and it's at 95% globally, and all of the major browsers support it, which is very, very good. And basically what I'm saying for this is that you never want to use var. There's almost no use case under which var is a really good idea anymore. Okay? Const is a very safe, sensible default to fall into because you don't want to redefine your variables unnecessarily. And if you then go to let because it's a little bit easier to type or it makes more aesthetic sense to you, you know what, that's actually okay too. But now, why don't we just fix var, right? And the reason why we don't fix var is because there's websites that may be dependent on their behavior. And rule number one is don't break the web. And this is an important facet of JavaScript, right? Because it has to always be backwards compatible, always. So we have to keep moving forward. And we've always got these knots and whorls to this tree that is JavaScript that we have to deal with. Moving on to the next section, we'll look at some emergent problems in arrays and looping. So we're going to discuss for in, for of, for each, and map. And you might be asking, well, why so many, right? Why are there so many arrays? Or ways of looping over arrays, and why do we care about the differences? And unfortunately for that, we need to start digging into the details of what they mean. So looking at a very simple numbers array, and a very simple for loop, right? We see something like this in almost every single C-like language, and it is a simple thing. It does exactly what we think it does, right? Except there's a subtle point here that clearly I'm raising this because it doesn't. That let, where does that belong? Does it belong to the block scope of the iteration, or does it belong to the context of the file? And in this case, actually it doesn't. It belongs in its own context. So it creates its own context of initialization just for that initialization of I. Then what happens as soon as you go to check the condition for the iteration, it creates a new context and then runs the code inside on that new context. So it literally copies across the variable. Then it goes to the incrementer, and there it does something different, a divergent code path. And it immediately goes and creates a new context of this, copies it across, and then iterates it. Goes back to the condition, back to the execution, and every single time it goes to the iterator now, it will create a new context. So the net result of this simple for loop is that we have 6 different contexts of variables. We've got the context of the script that we're running, we've got the initialization context, and we've got the context of every single iteration, which is far from simple, right? So there's got to be a better way. So let's look at something that looks like it does exactly what we want, which is for in. So the good news about for in is that in this case, let exists in the block scope of the for loop. And when we log it over, we get what we think are indexes for that array. So it does kind of what we'd expect a for loop to do, right? And obviously, it doesn't, because otherwise I wouldn't be making this belabored point. So we're going to take a look at iterating over an object rather than an array. And what does that even mean, right? What does it mean, iterating with a for loop over an object? And when we do that, we get a weird, unexpected result. We get 1, 2, 3, 4, which are the properties of the object. That's because the for in is not actually doing what we think it's doing as an iterator. It's iterating over the properties of whatever the thing may be. So if we were to patch in a foo method or a foo property onto our array, which we can do, I mean, maybe we shouldn't, but we can, and we loop over it, you can see very clearly that 0, 1, 2, and 3 are properties on that array that get created, that exist, that we can use. And this is not without value, it's just not something that we should necessarily reach for to iterate over the array. So let's look at something that's more useful. So if we look at the far newer one, which is for let of. So for of lets us iterate over each item of the array, and then when we go to trying to iterate over an object, we get a type error in JavaScript, because numbers aren't iterable, because this is an object. You're insane. Which is the kind of behavior that we'd expect out of this, right? And you'd be, and then when we look at iterating over more complex objects, we get the reference to each of those complex objects on each iteration of the loop, which is very useful, and like most modern programming languages. And you'd be forgiven for thinking that this was it. We were now going to use for of and for of forevermore. But wait. Remember this guy. Okay, wait. Just for a second, humor me. JavaScript also has this idea of a whole bunch of methods that exist on array. So like, for example, for each, which has exactly the same kinds of semantics as we had with the direct for of. And that lets us iterate over each element of that array and do something with it, right? Similarly, we can, inside our callback function, also get reference to the index and use the index. We can even get the whole array. I don't really know why you'd want to do that, but you can get the whole array as well. And do cool things. But now, why do we loop over arrays of things? Why do we loop over data? It's to do something with that data, and it's usually to mutate state or to create a different representation. And they've got something that does that, right? They've got an array.map function that says, I'm going to take one array, and I'm going to create some other representation of that array from it. So this one, very simply, takes in a function that is the callback that operates on each element, and it's going to say, well, I'm going to create an exponent of that, and then get a new array out of it. And we can even go further and use another array method called array.reduce and say, well, I'm now going to take that array, and I'm going to shape it differently, because I just care about the sum of the exponents. And I can say, well, I'm going to initialize the sum to 0, and on each one, I'm just going to add to it. Okay? But why? I mean, you could do that with a for loop as well. So I feel like I probably need to do a little bit more work to convince you of this one, but I'm going to put a pin in that, and we're going to get back to it just now. Map for, of, and for in have as close to perfect support as you'll get out of browsers, right? That's because they're ES5 standard stuff. They've been around forever. It's actually old stuff, but it's good stuff to use. I would say that because of what we're using here when we're iterating over things, map is definitely my favorite and my preferred gold standard for iterating. For of is in a distant second if you want to do imperative sort of iteration, and for in is in a third because if you want to do meta-programming, it's got some very, very cool features. Let's talk for a brief moment about context. And when I say context, I mean this, because it's driven many programmers mad, right? It's non-trivial, and I feel like we need to unpack that a little bit. So if we look at this, when you just run JavaScript, you'll get whatever the global object is. And inside a browser, that is the window. You get the window object. If you create a function and call that function, this exists as the window object in that function. In Node, it would be a little bit different, but it's still the same idea. Now, the reason why that's a problem is because functions have functions on them, like apply, for example's sake, where I can hypothetically define this object that is bar, and I can apply that object to the function, calling it and changing the context of this, which is weird. But even weirder, I can do something called bind and redefine that function and permanently change the context of this to bar in this case. So every single time it gets used forevermore, it will be set with bar. Now, that's weird and dangerous and can lead to something called a rogue bind. That's very difficult to debug when you're trying to look through a whole bunch of complicated software. And the reality is that if you use functions with DOM events, and this is a typical example of, we've got a click event, and I didn't remove the on click, it's actually click. We've got a click event that calls this foo function when it gets clicked. In that context, this is the HTML element. When we're dealing with inherited stuff, and we very quickly glossed over it, and we'll get back to some of this later, in the body of the constructor function, this is the constructor function, right? It's foo. It's the new thing that's been initialized. If we set it on the prototype, we get an exact reference to the thing, that the constructor function itself, the same this. But if we create a function that sits inside of the constructor function, we technically get an inherited this. So it looks like the same because it's prototypically copied across all of the properties, but it's not the same thing technically. If we do any kind of asynchronous work, in this case represented by a set timeout, we get unexpected results. Because in the set timeout, we go back to getting the window object, not necessarily this that we're expecting. And that's, when you stumble across things like this, very confusing. So there has to be a better way, right? And luckily there is. So we're going to look at something colloquially called fat arrow syntax, or arrow function expression, because, I mean, we don't want to pass value judgments on code. So what happens in the arrow functions is it doesn't actually have its own context of this. It takes the context of this from the lexical scope that it's declared in. Okay? It literally doesn't have it. So in this example, they both get set to window, and when we create it as a nested function that exists inside of a constructor function or some other function, it is literally the exact same reference of this. Not some inherited reference, literally the same function or variable. If we look at using it in terms of like the onClick event that we had earlier, in this case, passing an arrow function into the onClick will retain the context of this. So you can predict it more reliably. When you use it in context of a set timeout, because it doesn't have its own this, it again is very reliable. If we try and bind over it, right, with a rogue bind scenario that redefines it, it doesn't error out, which could be expected behavior. It still lets it pass, but it doesn't change the context of this, because it can't, right? Because this is not its to change, it belongs to the script file that it's been declared in. A small interesting caveat, something to remember, is that if we hypothetically have an object literal declaration, and inside that object literal declaration, we create a bar method as a function, right? That bar method has a context of this that is this object literal that was created. But if we then change it to be an arrow function, it doesn't have a context of this. The arrow function in that object literal inherits it from the block scope that it was created in, the window. And that's somewhat unintended behavior, right? So I'm not saying that functions are gone and arrow functions are the thing. Now, if we roll back a little bit, remember we were talking about the map reduce example. We can put a direct replacement for a normal function to an arrow function. Not really add much value. But the nice thing about arrow functions is that we can have an implicit return and then simplify them into a single line of code. And then we very expressively and eloquently can simplify our code to be clear as to what it's doing. I hope it's clear. And I mean, if that's not clear and readable, I'm not sure. You might be in the wrong. I don't know. I'm sorry. So, arrow functions, pretty good support. 92% of browsers globally, and importantly, all of the big browsers support it natively. I think that if you use arrow functions, you'll love them. They're really, really great. They make your code really expressive, really beautiful, and they give you very relatively reliable results when you deal with this. But it doesn't mean that you can pretend that this is now somehow safe. You still need to understand the idiosyncrasies. You still need to understand that context is a very hard problem in JavaScript. So let's move on from there to modules. So if we look at how we did modules previously, we used something called an immediately invoked function expression, which is a fancy way of saying we're creating a function and calling it immediately. Now, the reason why we did this is because there was no real privacy inside JavaScript. And if we created stuff inside this immediately scoped function, because it was anonymous, we wouldn't be able to access it outside the function. How we would then explicitly take stuff and expose it to other modules is we would pass in a module argument, and we would use a side effect of JavaScript, which is to say, well, if this module exists on window, pass it in. Otherwise, create a new module and pass it in. Or create a new module, set it, and pass it in. And this was really, really common. Another pattern that we would see a lot is something called revealing module, which is the exact same anonymous function declaration, but explicitly returning the things inside this big function class that I want to export everywhere else in my application. And there's some stuff that still works like this. But there has to be a better way, right? So if we, in new JavaScript, want to export a function, hypothetically assuming that this whole file is a module, we would just use the export syntax, right? Really, really simple. And the nice thing about that is that we can export anything that is a primitive that we can declare, consts, classes, whatever the case may be. And just by omitting that export, we can then hide stuff internally to a module. We also get the ability to use a revealing module-like approach and have a lot of stuff and then explicitly export at the bottom. And we can even re-alias the stuff that we're exporting, which is pretty cool. We can export default so that we can avoid curly braces, because apparently some people dislike curly braces. It's a thing. You can re-export stuff from another file, just passing it through. And importantly, we can use a side effect of the fact that the index.js in a directory is the same as importing or exporting from that directory. And we see a lot of modules, or sorry, a lot of libraries use this pattern to have lots of little JavaScript files that then have surface a very neat API to the rest of the application. And it lets you write really elegant, neat code. On the other side of it, because that's only half, we look at importing. So if you were to import, you would import foo in curly braces from this module that's foo. We can import multiple things. We can re-alias those things, which is sometimes useful, depending on how we've declared our variables locally. We can import splat, which is to say we want to treat it like a module, and we can meta-program against it, which is useful sometimes. Oopsie, too far. We can use the default imports, right, which is just basically getting rid of the curly braces. And hell, we can even mix and match curly braces and not curly braces. And I literally don't understand why you would want to do this. But here's looking at you react. And that's fine. This is called an import with side effects. And it's completely legal. But you're basically saying, I'm importing that file over there, and it's doing something, and I have no idea what. And I don't necessarily think, I think you should be careful if this is a pattern that you use quite a lot. Unexpected results. But again, so we've got the two sides of the JavaScript part, but JavaScript doesn't run divorced from a browser, right? It still needs to be linked somehow in HTML. So how we would do that is we would create a script tag that links to the source. Okay, cool. And now, all we would do is we would say, we want a script tag of type module that links to that exact same source file, and then we've got all of these semantics of proper modules. And importantly, that's not our only option. We can also then say, well, we're going to have a script tag of type module, and then we're going to import directly and initialize stuff ourselves. And this is very useful to use those two interchangeably. We have some support for a tag called noModule, because if a browser doesn't support script type module, it's going to say, oh, okay, cool, I've got a whole bunch of text here that I don't understand, so I'm going to ignore it. And those browsers typically then also implement something called noModule that says, well, if I can't do something meaningful with the module, I'm going to recognize that instead I need to run this other thing. And the browsers that support module will ignore the noModule script declaration. So this will let you run old JavaScript and new JavaScript sort of interchangeably. We also, everything up until this point has been referred to as sort of static modules, right? Static imports and exports. We have the ability to, using new browser features, have a dynamic import, which says, well, I'm going to, at runtime, go and import that file as a module. And then I can write a continuation and do stuff with that module. And this may seem a little bit esoteric, but give me a moment to work through an example. Hypothetically, you have a link on a website, right? And you want to, on the click event of that link, download the script that it's going to need when you navigate to the next page, perhaps initialize some stuff, and then only move to that page so that you can guarantee that it all works when you get there, right? So it lets us really succinctly and eloquently write lazy loading code. Module support is pretty good, so you can use it in most places, and all of the big browsers support it. And noModule, which is kind of important because the browsers that support noModule can't run modules, and it's a low number, so that's a little bit disappointing, if that makes sense. So the browsers that are in that 15 or 14.5%, they're the ones that actually need noModule. Anyway. Dynamic import doesn't paint as rosy a picture right now, because it's only really supported in Chrome and Safari. But I don't think this is a big issue because the latest beta of Firefox has this behind a flag, and I think they're going to make it public soon. And Edge is going to be based off of Chromium soon anyway, as of the next major release. So this will change really, really quickly. And there are also really good polyfills that you can use to be able to use dynamic imports now. So, statement. I don't think we really have a choice. I think you have to use modules. We can't just smash everything into one massive JavaScript file anymore. And I think that, well, I suppose you can, because it will still technically work. You do need to move forward and use this stuff. And I think that the real future here is dynamic imports and being able to very succinctly create not one big application, but lots of little bits of pieces of an application and only load it when you need to. So, inheritance. I was going to avoid talking about inheritance, but I decided that that created like a little bit of a straw man argument, right? I opened up with Java versus JavaScript and then made fun of JavaScript, and I feel like I kind of do need to show you the OO routine. So if we take a look at Java on the left and JavaScript on the right, okay, they both have class declarations. They both have constructor declarations. The only difference here, or constructor declarations, instance methods, static methods, the only difference is that Java has types and access modifiers that I've conveniently ignored here. If you want to use inheritance and call super methods, you can do that, right? The syntax looks almost identical. If you want to then have packages, you can have packages in Java and export modules from JavaScript. And I would personally argue that I think that modules are a little bit more modern and eloquent. But now, that doesn't mean that it isn't still JavaScript under the hood, right? Just because you've got some niceties. So let's take a look at some of the challenges with that. So we'll start off by looking at this, right? Because context is hard. So inside the constructor function, this is foo. Inside the instance methods, this is foo, okay? As we would expect. But now, as soon as you do any kind of DOM work and you try and bind your instance foo method onto like a click event, right? suddenly you're getting HTML element as this rather than foo. So you think you're in this OO-like world where you're working with an instance of an object, but you've still got all of the weirdnesses of dealing with context inside JavaScript normally. How you would get around this, how you could get around this in this example, is by explicitly creating a bind on foo and then redefining the foo that you've created as an instance variable and then saying, well, I want to pass through this directly. But that kind of feels like it's wrong, right? Because then why use class at all? So another way to do it is say, yes, well, we can use fat arrow syntax, right? Because then this will be retained from the constructor function. And this will work, and it'll work amazingly, and it'll be eloquent, except you've now got an anonymous reference to the thing that you're passing to the HTML event listener, and now how do you unsubscribe that? How do you remove that event from the DOM so that you don't have like rogue behavior or memory leaks? So what you would do is you would say, okay, fine, I can keep a reference on listener, put it on this, and then later when I've got a cleanup or dispose or unmount event, I can explicitly remove that event listener. But isn't that exactly what bar was doing in the first place? So you've now got two things, one wrapping the other thing, which is clunky and cumbersome, right? So I would obviously only take you down this path because I wanted to show you more functions. So let's talk about a different way. Let's talk about object literals, because JavaScript is great object literal support. We've got the ability to create this literal that is foo. We can set an instance property, and then we can set a function that has a reliable context of this. Okay? And let's for a second say we wanted to share the code of foo around, something that you would traditionally use inheritance for. So let's copy it using the spread operator. Okay? Let's do a shallow copy of all of those bits and pieces and see where we go. So we've now created a shallow copy of foo. We can then additionally override properties of it, so like changing baz, and then, hey, it actually all works together, right? We've now shared the code across from foo. We've got a copy of it. We've got completely different references, and the code works exactly like it's supposed to. Because there's magic in the spread operator that when you're copying it across into the object literal, sets the context of this correctly. And this leads to some really, really cool things. It gives us a very reliable model of not worrying about big inheritance hierarchy and being able to just shallow copy data across. And it synergizes very well with functions. So class support is pretty good, 92.3% if you wanted to use class, but just beware that it doesn't change any of the weirdnesses about context. You're still dealing with functions and binds and stuff. So just be careful. So I don't have enough time to talk about promises, but it is the last slot of the day, and I can't screw over any other speakers, so I'm going to anyway. So we've been using set timeout to kind of simulate this idea of doing asynchronous work, right? Now, set timeout uses a callback approach. If we were to introduce promises, which we alluded to earlier, basically all a promise is creating this thing that's got two callback functions, a resolve callback function and a reject callback function. And inside here, on the set timeout, after a second, we're going to resolve using foo. And that lets us write chainable thens, which are other functions that basically let us take in those, the stuff that was resolved, right? We can then also similarly, on whatever conditions, reject that thing and then have a catch continuation that catches that error. This is relatively straightforward. But let's move to a practical example and not use set timeout. So this is using the fetch API. And the fetch API is basically something responsible for doing a simple HTTP GET or POST asynchronously. And it returns a promise. Okay? So in our fetch API, if we're fetching this JPEG, we can then chain on that fetch and log the result, which is an HTTP result as we would expect, and then on error, catch the error. We can then additionally, on the outside of that method, because we're using the implicit returns of this promise chain, we can additionally say, well, go fetch foo and then do stuff with foo and not worry about the internals of that promise, which is pretty cool, right? So you've got this very nice chainable API. We can then go and plug into various points in time. So for example's sake, we're going to move over to using a JSON fetch, which is probably going to return some data that's probably going to be foo, and that result.json is actually also a promise that reads out the body and resolves to the continuation. So it works exactly like we expect, but now if the request fails for any point in time, we get an undefined exception, right? Because the JSON, like, it might not be a successful result. We might not actually have any data. So in that scenario, it'd be very reasonable for us to go and say, okay, cool, we're only going to do the result.json stuff if it's a HTTP code 200, right? Which is fine. But then we've got this weird thing on the outer continuation where we have foo when things go well, and we have undefined when it doesn't. And now we've got this blurred concerns that we have to care about the internal promise chain structure, right? We have to understand what it's doing under the hood. And that is an anti-pattern referred to as broken promise. And Ryan nodding sagely at the back can probably tell you a whole bunch more of those. So let's look at, obviously I'm going to introduce something different, right? We're going to use the fetch API again, and we're going to look at something called async await, which is a keyword that was introduced and exists in other languages, and it's an attempt to try and simplify this functional approach to asynchronous work. So you would declare your function as being async, and you would be able to await it, and it would give it this clue back that when it resolves, it needs to go to this point in time and execute to the next line. On the outside, you would await that function itself, and it would just all work. As it gets more complex, so for example, adding the JSON promise read, that would also be awaited, and it would still look exactly like imperative code that we expect. When we want to handle errors, we would just wrap things in a try-catch and have this very clear understanding of how things behave, right? Except I've lied to you a little bit, because this code won't work. And the reason why this code won't work is because that let foo equals await, fetch foo, would be a top-level await. Now, there are very serious performance considerations, and browsers don't want to implement a top-level await, so you always need to have your awaits inside an asynchronous function so that the browser very clearly understands how to optimize those, right? So your options are to either then resolve to promises on the outside, and that doesn't really get you anything, right? So you've got async await on the inside, giving you this imperative API, and on the outside, you're still using promises. So I think you should just wrap it in an async function and immediately invoke that function, and then everything's fine, right? Probably not. Promises are supported very, very well everywhere. Async await is supported okay everywhere. I think it's a larger footprint than I would feel comfortable using natively, but it is pretty well supported. If you think you're going to write good code using async await and you think imperatively, then go for it by all means. Live your best life. I just don't think that it makes that big a difference. I think that we need to face the reality that promises are both very, very difficult and very, very important. It's not something that's going away. There are lots of APIs, and all of the browser-native APIs use promises. I think it's important to understand it. Okay. We're going to close off with a brief discussion of transpilation. Okay. So what does transpilation mean? Transpilation is the translation from source code from one programming language into source code from another programming language, right? Not compiling, which generates bytecode, transpiling that generates other executable and compilable source code. Now, in our context, that means transpiling from JavaScript that's executable to JavaScript that's executable. And I mean, is that not just the most JavaScript answer you've ever heard of anything? But okay, let's roll with this, because I think it's really important. It is a reality right now. So there are two major transpilers, one being TypeScript and one being Babel. Now, TypeScript isn't really a true transpiler, because it's also trying to be a transpiler plus programming language, except it's basically just JavaScript plus, right? So if you feel types are exceptional and it makes you write better code, then go for it. But at the end of the day, it's just a transpiler. Babel is a truer transpiler that also has a lot of plugin support. And between the two of them, they cover a broad spread, and there are lots of levers that you can pull and tug at and generate very specific types of JavaScript and very specific versions of JavaScript. Okay? Because what I'm suggesting is that you should build and serve multiple versions of your own code, right? If the browser supports ES modules. You should give the browser ES modules. If it doesn't, you should give it something that it does, either ES 2015 or ES5, right? And figure that out either using browser semantics or using HTTP semantics, which ones you're going to support. This works everywhere because you're generating code that already runs and you're generating multiple versions of code for different browsers that you have to support. So I think it's a pretty good idea. So in conclusion, I think that they're dismissing the entirety of the language that has matured over the last 2 and a bit decades by some weird idiosyncrasies in a 10-day hackathon, I think might be a little bit premature. There's awesome stuff that's being done with the language, and there's awesome new features. And more importantly than that, it's very easy to get stuck into the programming languages or JavaScript is purely a transpiled. I can write code using the modern features and then just compile down or transpile down to old JavaScript code, but that means that you're serving massive files and leading to lots of data bloat over the wire, right? These things are available. If you can support the 4 major browsers, and I think it's reasonable that you do, you probably should, and you probably should use these features. That makes sense. So if anybody else has any questions, comments, or gestures, I'm open to it. Thank you. Yeah, go for it.
Just for the models, that's awesome. I don't know if I'm comfortable using the production yet until all the little quirks are worked out. Because how they download it still, it's not
Okay.
quite finalized. It's there, it's working. It's just not 100% yet. I know there's some new HTTP stuff coming out to make the HTML and stuff a lot better, so you can have multiple.
Okay, yeah, yeah, H2. Yeah, definitely, yeah. But I think the point is that you still need to potentially transpile code that'll work in browsers that, you know. Yeah, exactly. But I honestly, I believe that you don't really have a choice anymore. You have to. And I think the node pulling the trigger on modules now is probably the biggest indicator that it is a thing. Makes sense. And I'm so grateful we don't have to suffix everything with .mjs. That was making me sad, I'm not going to lie. There was a question earlier, yeah?
I think my major one is you mentioned that there's lots of weird stuff about JavaScript. And that might be true for other languages as well. But what do you like about JavaScript? What draws you back? Because I mean, it's very easy to...
Wait. So much for beer o'clock. You thought we were out of here. There it is. It's simple, it's expressive, it works everywhere. What's not to like, right?
So you triggered me, buddy. I can have the tool, but as if it's the right tool for the right job, that's it. You should be able to use any tool that's right for the purpose. It should be, it's a traffic tool for that. It's the right tool for that to start with. What don't you like about it?
No, I love JavaScript. I'm more... like people can make try and force JavaScript everywhere. And it's not necessarily the best tool, but it's workable.
If you've got a hammer that you really like, you can knock in any nail with it. But I think so. I do feel relatively strongly that if you're trying to do OO work in JavaScript, it's fooling you. It's not really OO. Now, my opinion is actually that you probably shouldn't be doing OO work anyway. But that's a contentious debate, and it's a safe space, right? I don't want to violate the code of conduct like at the 11th hour. We already had a fire alarm today.
I just wanted to comment on Don't Break the Web.
Yes.
I found out recently that that's the reason array.content is called array.content.
Yeah.
Because I think jQuery or one of those earlier libraries used to call it the truth.
Yes.
They couldn't call it a truth. They had to
Yes.
call it content.
There's a similar one with MooTool. I think it's MooTools with flat map and flat. That. Yeah. Yeah. Frederick.
Also supports import scripts. What is the difference between the import script of regelworkers and the import of the browser?
Okay, that's an interesting one. I don't think I can succinctly answer it, but we can have a conversation afterwards. It's very similar to the dynamic imports. The two are very closely related, but they're not the same, right? They've got different behavior. Sure. Instead of a dot for each. Because what are you? What are you even doing there? Like array dot for each over.
For each has the same syntax as a map reduce filter.
Except why are you mapping? And you're mapping because you work with arrays of data because you want to create a new array of data, or you want to simplify it so that you can show it in a scalar value. So map is the thing to use because it returns an array of data. Or filter, like if you want to limit some of the options. Dot for each really has no purpose. I don't even know why they did it.
Did they add it after for of?
No, I don't think so. I think that's probably why. I think it's older than for of. They were like, oh man, we made a mistake. And they do. It's evolution, right? Yeah. Okay, that's an interesting question. I think it's a good one. We can have this discussion. We probably might need more beer to have this discussion, but WebAssembly is not a replacement for JavaScript, very clearly. Okay. WebAssembly is to extend the capabilities of the web. Because I'm a firm believer that if you take a programming language written in WebAssembly, and then you teach it about all of the historical idiosyncrasies of the DOM and CSS and HTTP, and have it support something forevermore going forward, you would have recreated JavaScript. Well done. Because, that's what makes JavaScript complicated, right? You can't ever have a clean breaking version between things and fix old problems because it was released to the web. And rule number one is don't break the web. What WebAssembly gives you is it gives you the ability to write high-performance code and lift other applications and frameworks and business logic off of platforms that are no longer supported and move them into the web. Does that make sense? I think like one of the prime use cases was, name fails me now, the CAD tool, AutoCAD, right? Where their core code base was literally older than the web, if that makes sense. And they always wanted to have a web designer, but they could never really do it. And they managed to port that to WebAssembly and then load it up and have a good JavaScript front end in front of it and still use their historical code. So that's the real use case behind this stuff, not replacing JavaScript. Although I foresee that in 10 years' time, I'm going to have the exact same conversations. Because we had the conversations 10 years ago with Silverlight and Flash, and we know how that ended up, right? Yeah. Generators. Because I think I'm too dumb to understand generators. And they're not very well supported yet, right? So I don't necessarily think you need to write code using them. I don't think they're a core feature. I think they're esoteric. I felt guilty leaving out other features. Like I really should have spoken about template literals and tag template literals, because it's not just strings, right? It's magic. But then the talk is only so long. And like this is the stuff that people struggle with. It makes sense. Okay.